In this lesson, we're going to look at how to simplify fractions. So first thing I want you to pay attention to is fractions, remember, are rational numbers. We talked about that in the last lesson. So we're going to look at this first example where we're asked to reduce 6 over 8 into lowest terms. So there's a couple ways you can do it. Basically, since 6 and 8 are both composite numbers, what I can do is I can break these down into prime factorization. So if I have 6, if I think about the factors that go into 6, well, 1 and 6 and 2 and 3, I wouldn't want to use 1 and 6 because then I'm still left with 6. So 2 and 3, and then I check to see if those are prime numbers, which they are. So that means 6 is the same thing as 2 times 3 as a product of primes. And then if I do the same thing with 8, break that down. So 1 and 8, 2 and 4, I want to use 2 and 4 because I want to use something other than 8. And then when I look at this, 2 is prime, but 4 isn't. So 4 is going to break down to 2 times 2. So now I can express 8 as 2 times 2 times 2, or 2 to the third power, as a product of prime numbers. So then what I can do to actually reduce this fraction, 6 over 8, is I can take it, and instead of having 6 up top, I can write it as a product of its primes. So 2 times 3 is another way to write 6, according to this. And then 8, instead of writing 8, I can write 2 times 2 times 2. So 2 times 2 times 2. And then it's easy to see what terms cancel because I have a 2 up top and a 2 down here. So 2 divided by 2 is just 1. So really what I'm left with now is a 3 up top because this became a 1. And on the bottom, 1 times 2 times 2, so I'm left with 4. So that's one way to simplify fractions. You might be thinking, well, that's kind of a long way of doing it. So there is another way that's a little bit shorter, and it's basically just to look at 6 over 8 and decide, is there a number that goes into both 6 and 8? So in this case, 2 goes into both 6 and 8. So what I can do is just divide the top and bottom. You do have to make sure you divide both the top and the bottom because then you're not really changing the fraction. And if I divide the top by 2, I get 3. If I divide the bottom by 2, I get 4. So either way, I'm getting the same answer. This is definitely the quicker method, but when you have bigger numbers, this isn't going to always be the easiest method. This prime factorization works nice when you have bigger numbers, when you're not sure what the largest number that goes into both are. Another thing to point out here is, well, what happens if I picked a number but it wasn't the largest number that I could divide both the top and bottom by? Then you might get something over here that still has a common factor in it, and then you just reduce it again. So just keep that in mind. But let's look at some other examples so you can kind of see what I mean. So we're just going to write these in here. So I have a couple here to look at. So let's reduce 12 over 15. So I'm going to do it using the prime factorization just to review that with you. So I'm going to have 12, break that up. So 3 times 4 gives me 12. Break up 4 into 2 times 2. So up top here, so 12 over 15. 12 is really the same thing as 3 times 2 times 2. And then I'm going to break up 15 as 3 and 5, which are both prime. So on the bottom, I'm going to have 3 times 5. Cancel anything from top and bottom. So basically, you're just dividing it. So you're left with 1 when you divide 3 divided by 3. So then I'm left with 4 over 5. So that's it reduced. Now again, remember, you might be thinking, well, I could have just divided the top and the bottom by 3. So I could have just gone from this step to my final answer because 3 is the common factor in both the top and the bottom. So I could have just divided the top and bottom by 3, and I would have gotten right to 4 over 5. So the same thing, and if you notice, that number that's the common factor is the piece that's getting divided out. So if we look at one more of these, so I'm going to reduce 105 divided by 30. So here's an example where you might not know what the common factor is or the largest common factor between these. So using your prime factorization can really help with that. So if I take 105, usually numbers that end in 5 are going to be divisible by 5. So if you check dividing by 5, it's going to be 5 times 21. So 5 is a prime number, but 21 is going to break down to 3 and 7. So I can rewrite, so I'm just going to do this over here. I can rewrite this as 5 times 3 times 7. And then on the bottom, I have 30. So if I break that up, I can break it up into 3 and 10. Remember, these factors that you picked um, don't necessarily matter. So if I would have picked 5 and 6, that would have been totally fine. In the end, you get the same answer. So you just find any two factors that go into here. So then you stop once you get prime numbers. So then break up 10, so 2 and 5, which are both prime. So that's the prime factorization. So on the bottom, I have 3 times 2 times 5. So then if I cancel out anything from top and the bottom, that's the same. I'm left with 7 over 2. Now keep in mind, remember what I said up top here was whatever I canceled out is actually the highest number that goes into both of these. So if you look here, I really canceled out a 5 times 3 from top and bottom. So really the biggest number that goes into both 105 and 30 is 15, because 5 times 3 is 15. So I could have just said, okay, divide everything by 15, and I would have gotten down to 7 over 2, which doesn't have any common factors left. Now, if let's say you decided, okay, I'm going to divide everything by 5, that would have been fine. You would have been left with 21 over 6, and then you would have seen that 21 and 6 both have a common factor of 3, so you would have reduced it further. So this is just a strategy that helps when you get bigger numbers and you don't want to have to guess and check, but it's totally fine just to reduce by finding out the common factors, just always making sure that you check your final numerator and denominator, making sure that there's no common factors left. So then let's just look at one more example that involves us reducing. So if we go to the next page, example 3 is talking about Laura that's having a party. She puts 4 6-packs of soda in a cooler for her guests. At the end of the party, she finds that only 4 sodas have been consumed. What fraction of the sodas are left? Write your answer in lowest terms. So basically, she's putting 4 6-packs. So the total number of soda then, so let's just write that down. So total soda. If she has 4 6-packs, well, 4 times 6 is 24 sodas. So that's the total number of sodas. And at the end of the party, she finds that only 4 sodas have been consumed. So that means if there was 24 to start and only 4 have been consumed, so 24 minus 4 means that there's 20 sodas left. So we start with 24, 4 are gone, so we subtract those, and now we're left with 20 sodas. So we want to figure out what fraction of the sodas are left. So how many are left? So the number left over the total amount that we started with. That's really what we're asking. So fraction is always the part over the whole. So the part that we're looking for is how many are left. So the number of sodas left are 20 divided by the total, which is 24. And we want to write our answer in lowest terms. So technically, yes, this is an answer, but we want to get it into lowest terms. So I look for a number that goes into both 20 and 24. So there's a couple options here. If you start with thinking, okay, 2, well, let's see what happens. If I divide the top and bottom by 2, well, I'm left with 10 over 12. And then I check these. Do they still have a common factor? And they do, which is 2. So I would have to divide again the top and bottom by 2. And I'm left with 5 over 6. 5 and 6 don't have any common factors, so that would be the fraction in lowest terms. But what happens if right away you just saw, okay, well, 20 over 24, okay, the highest factor that they both have in common is 4, then you might have just said, well, I'm going to divide both the top and bottom by 4 to start. And then you would have seen 20 divided by 4, 5, 24 divided by 4, 6. You would have got 5 over 6 right from the start. So I just wanted to show you that in case you didn't get the highest factor first, it's okay. You just have to make sure you check the next fraction that you get. So really I divided by 2 and then divided by 2 again. So really I just divided by 4. You can also do the prime factorization where you break up the factor tree and use the product of the primes to factor as well. So however you want to do it, up to you.